In this video, we're going to talk about one of the three tools that we often use in conjunction with calculating probabilities. The first is called a contingency table, and we've seen it before and we called it a two-way table. And it's called a two-way table because we usually build these tables when we're comparing two different variables. So for example, students in my AP statistics class constructed a contingency table for hair color versus eye color. And I did this in all three of my AP stats classes this year. The data for one of my classes is shown in the table below. So this data is from one of my classes, and you can see hair color is along the top, eye color is along the sides, and you'll notice in both cases it's not every option in the whole world, it's the options that we saw in my class. You'll notice green isn't in the eye colors because there weren't any green-eyed kids in this particular class section. So we're going to use this table based on my students to find the probability for a randomly selected student in this class. So the first probability says find the probability for brown eyes. So what we're finding is the probability that a randomly selected student in my class has brown eyes. So we're going to set this up exactly like we did any other theoretical probability. The idea is the same. How many brown-eyed kids were there in the room? How many total kids were in the room? And looking at my table, I can see that brown is here. My eye color is one of the rows. And if I read all the way out, I had a total of 27 brown-eyed students. They're broken down here by hair color, but that's the total number of brown-eyed students. So I had 27 brown-eyed students out of 30 students. And so we'll do 27 divided by 30, and I get 0.9. So 90% of the students in that class period have brown eyes. The next probability says brown eyes and brown hair. So we're looking for the probability that a student has both brown eyes and brown hair. Oops, I don't know why I wrote equal signs twice there. So I'll set up my probability fraction. The denominator is the same. If I'm randomly selecting a student from the class, I have 30 to choose from. And I'm looking in this case for the intersection of brown eyes and brown hair. So here is the brown eyes row. Here is the brown hair color. That intersection, there were 16 students with both brown eyes and brown hair. So this would be 16 out of 30, which is 0.5333, or 53.33% of my class. The next question you'll notice is worded a little bit differently. It says find the probability that they have brown eyes given that they have brown hair. So P brown eyes given brown hair. And I remember from a previous video that the probability of B given A is equal to P both, so P A and B, divided by the probability of the conditional P A. So in this case, first I'm going to look at the probability of brown eyes and brown hair. And we just did that. That was our answer to B. So I know that this is 16 over 30 on top. On bottom, I need the conditional probability. the probability they had brown hair. So I need to go back to my table. We haven't done that one yet. And I go to the hair color, which is the columns, and looking at the brown column, 18 students had brown hair. So this would be 18 out of 30. I know that when I divide fractions, I take the numerator and I multiply it by the reciprocal of the denominator, meaning I take that bottom fraction and I flip it. 30 on top, 18 on bottom. And you'll notice those 30s are going to cancel. So what I actually get is 16 over 18. And that's 0.8889, or 88.89%. So knowing that a student has brown hair, there's an 88.89% chance that they're also going to have brown eyes. You'll notice in this fraction that we have at the end, that's the number of brown eye and brown hair kids, and that this is the number of brown hair kids. So dividing by the frequency of the and the frequency of just the condition gives us the same answer as dividing by the probability. So when we're doing conditional probability from a two-way table or contingency table, it's enough to just look at the frequencies. How many students were in the and, how many students had brown hair. We're going to use that shortcut for the next question, which says, find the probability of brown hair given that they had brown eyes. This is backwards. Oops. So probability of brown hair, knowing that my student has brown eyes. So I'm going to skip this step, and I'm going to go right to this step with the frequencies. And I know the top should be the probability of both, which we have from before. There are 16 students with brown hair and brown eyes. I need to know the number of students with brown eyes. So I go back up to my table, eye color, here is my brown row. 27 students have brown eyes. So the bottom of this fraction would be 27. And we get 16 divided by 27, which is 0.5926. And what that means is, knowing that my student has brown eyes, there's a 59.26% chance they also have brown hair. Notice that's different than the other direction. Knowing they have brown hair, there's an 88.89% chance they also have brown eyes. So when we're talking about conditionals, which one is in back, which one we know has already happened, will affect the answer that we get. All right, so that's how we calculate probabilities from contingency tables. If you have any questions about this video, feel free to send me an email or drop by office hours on Thursday. Otherwise, I'll see you in the next video.